what's going on, guys? Welcome back. Today we are finishing up Introduction to Networking on Hack the Box Academy. Now, this one is a lot of reading. So I've had some comments, excuse me, while I get my chair in order here. I've had some comments, really only like one or two, that actually asked me to read the material. They said that basically, and I understand their perspective, right, is that I'm skimming through it. Keep in mind, that's intentional. I'm not going to read this to you. You guys know how to read. The idea is that I give you more insight to the context of the reading, so when you're reading it, it makes more sense. That's the idea. My idea is not to read this verbatim and teach this to you verbatim. I'm going to teach you more insight that they don't give. That's the concept of the video. So please let me know in the comments below if you guys disagree with that methodology, if you think that I should read it to you and then explain, like, how do you guys want it, right? Because I'm using this time to teach you. So let's, work together on this. So let's go ahead and get started. Hit that like button, hit that sub button, all that jazz. You guys know what to do. I appreciate it more than you know. Let's get going. So we're going to start with networking key terminology. So we left off last time at right here, addressing. Now we're on protocols and terminology. I'm not going to read these for you verbatim, and this is why, right? Look at all these protocols, right? Or all these terminologies, I should say. They're not all protocols. And they're just telling you what they are so that you are familiar with them. Now, 90% of these, if you've worked in IT for a while, you probably are just familiar with them. This is why you guys see in all my videos, I talk about learn fundamentals first. Learn fundamentals first. This is why. Because it's almost impossible to sit here and say, okay, memorize these. Because you're not going to. But I can promise you, if you've worked with these, you will know them, right? So let's go ahead and start with some of them that are important. WEP, I'm not going to cover too much. It's outdated. We're going to get into it later. Secure shell, again, we're going to get into most of these later. So that's why I'm going to skip through some of them. Secure shell, this is something that we actually use on the video all the time. We SSH into something, and what you're doing is you're actually just getting a command line or terminal, and you're getting a shell, meaning you're able to access the machine and actually run commands. FTP, this is file transfer protocol, where you transfer files. Makes sense, right? Simple mail transfer, not going to explain it. HTTP, again, it's deprecated. They use HTTPS now, and we'll kind of dive into some of that later. SNMP, NFS, all this stuff, great. You guys just need to know what they are. Some of them that are actually relevant to networking, open shortest path first. So this is an actual routing traffic, basically shortest path first, right? It's going to try to determine what's the shortest path to send traffic, right? These are networking terminologies. The interior gateway protocol, as you see, is Cisco's proprietary interior gateway protocol, meaning Cisco designed it, right? So it's, again, routing. So all these things are great. PGP, not really relevant here for networking, but we're going to talk about some of this stuff. So we're going to get into a lot of this. This is why I don't want to just sit here and read to you guys this terminology, right? They're preparing you for the content that we're about to discuss, so you understand when they say something like URL, you know what it is, right? That's what they're doing. So let's go ahead and now common protocols. Again, some of these we're going to talk about. Some of these I'm just going to skip past because they're not relevant to networking. And that's one thing I've talked about 100 times, but I don't love about Hack the Box. I think they have very good content, but you have to sift through the weeds to find that very good content because they have so much wasted content. And what I mean by that is I'll show you. So on the network right here, there's two types of data. There's TCP and UDP. We've talked about this before on this channel, but TCP is transmission control and UDP is user diagram protocol, right? So what this means is TCP is connection oriented and UDP is connectionless. All that means, it's super simple, right? Let's say every time we had a conversation, I have to shake your hand. I have to shake your hand, and we have to have this handshake going at all times, or else we're not going to have a conversation. And the reason for that is to prevent noise, right? It's to prevent people from listening. We're only going to talk when we have our handshakes. So that way we know it's safe to talk, right? Let's say think about it that way. That's all you're doing. You're making sure 100% I'm connected to this person, and I'm not going to share information until I'm connected, until I know for a fact we're locked, right? UDP is the opposite. Think about like Netflix or any of those things where they're just spraying information. It's not a big deal if you lose a few packets, right? If you're watching Netflix or whatever, any of these streaming platforms, gaming, any of that stuff, if you're watching these and playing and stuff like that, and all of a sudden you lose like some audio, or like you notice it gets blurry for a split second and then keeps going, that's because you're not receiving every single packet, right? It's not a big deal. You can move on. You're not going to miss the show because you missed one packet, right? So think of it this way. TCP, they send you a packet. They go 1, 2, 3, 4, 5, 6, 7, right? If you don't get 5, you're not going to see 6 and 7. You're just going to wait for them until 5 comes in. If you don't get 5, it's going to send again, 5 again. Okay. And it's going to come in order, right? UDP, if you go 1, 2, 3, 4, 6, 7, 8, 10, and you're skipping packets because you're not receiving them, they get dropped, they get corrupted, whatever. Cool. Keep going. Send me all the data. I will receive it. That's the main difference. Okay. So these are TCP connections. So the one I want to talk about here is Telnet. There's a lot of confusion on Telnet. It's an outdated or deprecated protocol, but it's still very useful. Telnet is a protocol that accepts connection, or allows you to connect to something, right, on a machine, any port, whatever. Well, Telnet, the nice thing with it is it actually communicates using the terminology, syntax, all that the protocol that it connects to is using. So for instance, you see that SSH is on 22. If I connect using Telnet to port 22, I'm now speaking secure shell in the sense of that's what I need to be typing, right? Same thing with SNMP, whatever. But Telnet allows you to connect to protocols that you may not know what language it's talking. And when I say language, I'm not talking about, from an English, Chinese, Russian perspective. I'm talking about from a computer perspective, right? From talking computer talk, as you want to say. Now, we know HTTPS and HTTP are connection TCP protocols because when you go to a website, you don't only see some of the content, right? You're getting it all because you're waiting till it loads because you're waiting for it, right? You're connected to them. And we're going to dive into some of the HTTPS stuff later, but HTTPS is hypertext transfer protocol secure. It's because it's encrypted. That's the only difference. So there is a key exchange that happens that we'll talk about, and that's where that's a little bit more, but that's more of the handshake process. DNS, this is where you look up your actual IPs to your names, right? These are all connection oriented because you need to validate the data, right? So that's kind of what they're just continuously saying is these are the protocols that are important for TCP connection because you need to validate the data. Again, Squid Web Proxy, if I'm going to be connecting to a website, right, it doesn't do me any good to have a proxy there if the proxy's dropping packets or missing them, right? So I need it to be connection oriented. Now, user datagram protocol, you can see is connection list, which means it does not establish that virtual connection. So some of the things that do this, you can see DNS is typically a UDP protocol, but can be TCP as well. And that's why we showed up there. Why? Because usually a DNS packet, you're just asking for a quick thing, right? If it doesn't get there, you're not going to get a response. You just send it again. That's why DNS is typically UDP. It's not necessary to make it TCP, but you can have TCP DNS traffic, especially if you're going to encrypt it and things like that. And that's why it's on there both. Now, some of the ones that you're going to see a little bit more, for instance, Telnet. You might say, well, that was up in TCP also. Again, it takes on the form, if you will, of what it's connecting to. So if you're talking to a UDP, it can talk to a UDP, right? So really, really nice. Let's see what else we got. Internet Relay Chat. So IRC. This is something that's been around for a long time. It's internet text messaging, right? We're chatting, right? Okay, if we're chatting, if you drop a packet, is it the end of the world? Is the chat going to completely fall apart? Whatever? No. It's not going to, right? So things like that. Internet key exchange, it's protocol for encrypting and signing data. Guess what? If I don't get the full packet for the signing and encrypting of the data, I can't read the data. So ask again, right? You don't need to say, okay, we're locked in, right? You can say, the data is still encrypted. Send me it again, right? So it doesn't need it. So that's kind of the difference. Now, ICMP, this gets confused a lot because a lot of attackers use Nmap, right? And that uses ICMP packets. A lot of people think ICMP and TCP are the same thing necessarily, and they're not. ICMP is ran over TCP. But basically, this is the protocol that's used by devices to communicate with each other on the internet for various purposes. So this is kind of the next layer that you need to standardize. And what I mean by that is you'll see, so you have like a ping request, right? Which is ICMP, which is what most people are familiar with. Well, if we don't standardize that protocol when we're sending something like that, when we're just saying, hey, are you there? If we don't standardize the response we're going to get back, things like that, we're going to get gibberish because everybody's going to do it differently, and we need it all to be the same. So that's where ICMP comes in. And you can see it sends you things such as destination unreachable that you see in ping, time exceeded. Those are messages that are already pre-programmed in there, and that's why we use that protocol, because if we didn't, we would just not get a response, because if it's unreachable, we're not going to get a response, right? So if we don't put something there to, what's the right word, to prepare for these cases, right, then we will just get no response and have no idea what to do. So we have the echo request, which is your ping, right? You have your tracer. So tracer is going to be, hey, we're going to follow the path and see what you're doing, right? All right. Timestamp request, again, just give us the timestamp, right? We have the reply, because when you send a echo request, you expect a reply, right? You would typically expect it. Time exceeded, if it's taking too long, it's going to say, hey, time exceeded. That's important because you don't want a packet just to live forever out there, right? So there's all these things, and you guys can read through these, but just know the difference, right? That's the big thing. The time to live field, this is a big one in ICMP, because this is actually one that we as attackers can utilize for multiple things, and people don't realize it, but this is kind of the mentality of hackers, and it's really cool to see. This is why I got into hacking initially, was because I find it so interesting the way people can think of things like this, right? So let me explain what I'm talking about. Okay, let's say we're trying to figure out, right, your network. Okay, well, let's say we try to use tracer and it's disabled. Okay, that means I can't get the exact path that it's taking. But let's say I'm in your network and I'm trying to talk to someone over here. I don't know how many hops it is. I don't know how many routers, switches, whatever it goes through. And I don't know, maybe there's another, for instance, if I'm trying to talk to SQL, right? Typically, there's going to be like a web interface or something that you're interacting with, and then you're hopping into the SQL database, right? And then in between it, there might be a firewall, there might be, another router, whatever, as it gets through there. Well, time to live can tell us a lot, because guess what? Every time it touches something, that time to live decreases by 1. So what I mean by that is, if we set the time to live value to 1, and I send it, it'll come back and say unreachable, right? Time exceeded. Why? Because it reached 0 right after it touched the first machine. So now let's add 2. Okay, now it's hopped twice and it still died. Now 3. It's hopped 3 times, it still died. 4. Hopped 4 times, still 5. 5 came back with a response. That tells me I have to get through 5 things before I touch that server. So right away, I know there's some defense in there, right? Even if it's not intentional defense, it's defense in depth, meaning, hey, they've got 5 hops I have to hop to get there. So maybe that's not my target right now. Maybe I'm looking for a target with 1 hop, maybe 2, maybe 5 hops right now is not my target because I don't have the recon, right? So that's one thing. The other thing that's really nice is we can actually use time to live to determine operating system. And you can see, because Windows has a default operating system of 128, right? Okay, cool. Mac OS has a default of 64, Solaris 255. So right off the bat, we can start to see by the default packets, what is our operating system? Now, this is not a foolproof plan, right? You can change it, time to live, you can do all that. So don't take this and go, boom, I know what it is, right? Because if you have a savvy Linux user who's like, hey, I changed my time to live to 128 so people think it's Windows, well, there you go. You don't want to just rely on that. Now, those are some of the methods. Now we have VoIP, right? So VoIP is something you guys are all familiar with, even if you don't know it. You're using Skype, you're using Slack, Zoom, Teams, whatever, right? And you can see they're used for session initiation protocol, okay? Not every VoIP system uses this, but that's what they're going to cover a little bit. Now, this is the signal protocol for initiating, maintaining, modifying, and terminating real-time sessions, meaning we set up the call, we talk, we end the call, right? That's the phase. So here's some of the things that you're going to see in that. You're going to see the methodology. When I say the method, they're saying this is the flags basically you're sending to them. You're saying, hey, I have an invite, and the invite is the session. Hey, do you want to join, right? The ACK, which is similar to the TCP handshake, right? I accept, I acknowledge the invite, and then when we're done, okay, bye, we're done. Then you have your cancel, which is going to cancel the invite, right? You register a new SIP user agent. Okay, what that means is like I logged in, maybe I'm using the web browser, and I say, hey, I want to, invite somebody. You need to register what you're using, your user agent, which would be your browser in this sense, to the server so it knows who you are, right? Because it may not want certain things. Like for instance, if your default user agent at your company is Chrome, but you're trying to register with Firefox, it may say you don't work for us, right? It's a very small security feature because you can just change the user agent, but it's something, right? All right, now options. This is a big one because you can get information, right? So that's where information disclosure comes. So you can use the SIP options request, and you can actually use that to gather information about users. And some of the stuff, this is where I think Hack the Box does poorly. And what I mean is we're talking about networking here. This is intro to networking fundamentals. I can understand all of explaining SIP, right? Where you lose me is now, okay, it's possible to discover this SIP config file where there's this unique identifier in a configuration file by Cisco Unified Communication. That has absolutely nothing to do with network fundamentals. They are talking about a more sophisticated attack that you are not ready for, and that's not being a jerk. It makes no sense for you to hop from, I know SIP, which is, I just learned right here, that session initiation protocol, I just learned it, to, okay, now I'm discovering a config file. It doesn't make any sense. You don't know the network fundamentals yet. So let's move on. I'm just trying to weed you guys out of the fluff, right? So wireless networks. So a lot of people think of wireless networks and they think of just Wi-Fi, right? That's just not the case. There's wireless networks all over. There's Bluetooth, there's Wi-Fi, there's RF, there's 5G, there's LTE, all this stuff, 3G, the older school stuff. There's all kinds of them, right? So you can see, I'm not going to dive too deep into all of them, right? But just know that anything that goes wirelessly, right, is sending out frequencies, is wireless, right? Makes sense, obviously, but not everybody thinks of them that way. Meaning you can intercept them, you can send them, you can block them, you can do all of it, right? There's all kinds of this all over the world. It happens all the time. There's certain radio frequencies that you actually legally can't use because they're for emergencies, things like that, right? So this is what we first think of, right, is the wireless access point. So this is where communication between devices occurs over RF in 2.4 gigahertz and 5 gigahertz. This is what you see on your Wi-Fi when you're saying, I have a 5G Wi-Fi and a 2.4. It may not say 2.4, it may just say regular. I know like my router, my wireless access point, it will actually say, do you want to connect to the regular or do you want to connect to the 5G, right? That is, and now I think they're getting ready to come out with a new one. But anyway, this is where you're sending it over the gigahertz. That's the frequency you're sending it over. Okay, so understand 5 gigahertz, faster, but has less travel time. It can't go as far, right? Because you'll start to drop off. So this is your wireless access point to request permission to transmit, blah, blah, blah. This is your central. You guys all probably have a Wi-Fi router, and it sends out data, right? It allows you to connect. It allows you all that stuff. You guys probably all have one. That's what this is. So now you have your Wi-Fi connection. You have your SSID. That's the name. You have your password. That's your password. I'm sure you guys are all familiar with this, but you don't realize how it relates to networking because the principles, the underlying principles are the same. Once you're connected to that wireless access point, it just connects to a cable, right? The same thing as a regular connection. You're just extending that connection wirelessly a little bit. So you can see the 802.11, that's the known protocol. Everyone, you can look this up if you want. It's a pretty large document, but 802.11, this protocol defines technical details. Again, a lot of people get hung up on protocols and things, and they say, well, how do you know that? It's just a standard. What I mean by that is, if we didn't set a standard, you would go buy a router or access point from our Walmart, right? You'd buy that. When you buy it, guess what? It may work, it may not. Why? Because they may just make up how they did it. They may do something totally different than everybody else. And your computer's like, I don't even know what the hell they're talking about, right? You have to set a standard. It's kind of like when you go to a country, they have an actual official language. That's the language that country has agreed to talk on, right? In America, it's English, obviously, right? So we've agreed that this is the language we're going to use. If you don't do that in computers, nobody knows what's going on, right? You may buy a product for $100,000 thinking it's a great product, and it doesn't work with any of your stuff. You have to have a standard, and that's all this is. That's all these protocols are, is they're standards, right? So keep that in mind. Now, the connection request frame contains various fields, including, so this is some of the stuff they include, the MAC address. This is your hard-coded MAC address. SSID, the name, right? Supported data rates. How fast can we actually communicate on both devices? Because that's another thing people get confused. Just because you have a 1 gigabyte up and down speed doesn't mean your computer can talk that fast, right? So you're only going to go as fast as your slowest device. And then what security protocols do you support, right? Maybe I have it hardened to where I only allow you to connect with these security protocols, and your device is like, I don't have those security protocols. I don't know what they are, so I can't connect, right? Those are some of the things. Now, the WEP challenge response handshake. This is basically allows you to establish a wireless access, establish a connection with a wireless access point and client using the WEP security protocol. This is outdated. I'm not going to dive too deep into it because nobody should be using this really, but maybe some people do. Okay, so some packets can get lost, and the so-called checksum has been integrated. Okay, let's see what it says. Has a flaw. Yeah, it allows us to decrypt a single packet without knowing the encryption key. It's because the value is calculated using plain text data, meaning we can see it, the data needed to decrypt it. So we can actually just decrypt it. That's why it's outdated. That's why people don't really use it. Maybe you'll get lucky and find it somewhere. It's still in the wild. It's still there. But so Wi-Fi networks have several security features to protect against unauthorized access. Encryption. That's a big one, right? If we encrypt the data, you can sit there and you can capture the packets out of the air all day long. But if you can't decrypt them, okay. Access control. Who has access to the machine or to the wireless access point, right? If we control who accesses it, then we're good. Firewall. Again, okay, if we can control who can actually touch it, then we should be good, right? Now, obviously, it's more complex than that, but that's the simple part, right? So you can see we can use various encryption algorithms. These are some of them. You can click on them and learn more if you want. Access control, pretty easy, right? Only allow authorized devices. Firewall, you guys know what a firewall is. Encryption protocols, VoIP, we're not going to talk too much about it. These are how the protocols work, right? WPA has a pre-shared key, okay, which provides stronger protection against unauthorized access. Although older devices may not support WPA, which nowadays I don't know any devices that don't support it. Generally, yeah, you should be using WPA2 or even WPA3, 100%. Anywhere you go, should be using it. If you're not, change it, okay? So now we have lightweight extensible authentication protocol, blah, 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 blah. These are authentication protocols used to secure wireless networks to provide a secure method for authenticating devices. They're saying the same thing, okay? They're just different protocols. That's it. Maybe you have a device that only can use LEAP, or maybe you have a device that can only use PEEP, or maybe you have a device that can only use WPA3 or whatever. These are different protocols that you can use, right? So this is a framework for authentication used in various network contexts. However, one key difference is how they secure the authentication process. So LEAP uses a shared key, okay, which means they use the same key, okay, for authentication and encryption. The same key, okay? This can make it relatively easy for us to gain access to the network, because if we have the key, we can now authenticate and encrypt, right? If you use two separate ones, we may have a username and password, but we may not be able to decrypt the data, right? So that's where now PEEP uses TLS, which TLS is the standard nowadays. You should be using TLS on everything. So this method establishes a connection between using a digital certificate. If you don't know what this is, this means a certificate authority, somebody that you declare, and I say you declare as in everyone agrees on, is going to be the authority, right? They're going to say, I will give you a digital cert to say you are who you are, and you have to register with me, right? So that I can validate Stuffy has this cert validated by me. And that cert is a large code of random encrypted text that is the key, basically, right? Okay. TACAX server, it's unlikely. Okay, so this is an actual server, the TACAX Plus, right? When I say server, keep in mind that your router can host this too. Sends an authentication request to the server, is likely the entire request packet will be encrypted to protect confidentiality. This is more large scale. Just know that this isn't what you're going to find on your home router. Typically, you can set it up if you want, but it's not typically something you're going to see all the time. So it's used to authenticate and authorize users accessing network devices such as routers. When the wireless access point sends an authentication request to the TACAX server, right? The request includes the user's credentials and other information about the session. It then validates them, right? So this is why it's larger scale, because typically all that can be done on your home wireless access point, whereas in a large scale network, you may have something else as your authoritative server, which is your authentication, or excuse me, your authority of who can log in and who can't, right? Now, a disassociation attack, this is, everything's vulnerable to this because it's in the wire, it's in the wide open, right? What it is we're going to tell your client, your computer, your phone, whatever, to disconnect from the machine, right? And then they have to reconnect. Why is that important? Because when they reconnect, we're capturing the reconnection and we're capturing the authentication. Even if it's encrypted, we might be able to take that offline and go decrypt it or try to break it, right? But this is something that's very common. Everyone's susceptible to it. Why? Because nobody can stop you from, whether they make it legal or not, but nobody can stop you from sending a packet to if my phone is listening, nobody can stop you from sending a packet to it and saying, hey, disconnect, right? Nobody's going to stop. Now, my phone might go disconnect and then go, oh, it's back up, reconnect, right? But nobody's stopping you. That's how people can disrupt, right? So now wireless hardening, you can disable the broadcasting, Wi-Fi protected access, MAC filtering, and deploying TLS, right? So disable broadcasting. Just don't make it the SSID broadcasted, right? Now that might sound really complex. It's not. It still can be found. This isn't super secure. You can still find it. It just means we're not showing random people that go down the street and look at their phone. It's not going to pop up, right? WPA provides strong encryption. We've already talked about it. Use WPA 2 or 3. MAC filtering. This is, hey, I know the MAC address of my phone. I know the MAC address of my computer. I put them in. They can connect to it, but nothing else can. This is, again, somewhat secure, but the reality is if I monitor the network, I can see that your MAC is on it, and then I can actually just take your MAC and spoof mine and say I'm you. Now, deploying TLS, again, It's the standard, so that's why you deploy it, right? Okay, let's keep going. VPNs. All right, we're not almost done. Okay, we're gonna have to start going a little faster. So VPNs. If you guys don't know what this is just you encrypting data with another endpoint, which could be a server, it could be a website, it could be something you set up, it could be whatever, your company, whatever. And what it is you're setting this encryption up so that I'm going to connect to this encrypted device, right? Which is typically like a Global Protect, AnyConnect, any of these VPNs, OpenConnect or OpenVPN, excuse me, any of these VPN systems where on the other side it's waiting for the connection, and once you establish connection, you're validating because you're authenticating to it. And when you authenticate, now it's as if I'm inside the network because I have that encrypted channel. Anything coming in and out of this encrypted channel is encrypted. Nobody can see it. Nobody knows what I'm sending. So it's a way for me to trust that even though I'm not sitting physically where I'm plugged into the switch, I can actually connect to everything as if I'm just sitting in that building. So that's the point of a VPN, right? Most of you are familiar with the VPN. That's a general overview. So that you have the VPN client, that's you, that's whoever's connecting to it, right? The computer, whatever. The server, that's what's waiting for your connection and listening. Encryption, that's whatever encrypted protocol or algorithm that you guys decide to use to encrypt that data. And then authentication. A lot of people get encryption and authentication confused. It's separate. So what I mean by that is I might say my username's stuffy, my password's stuffy, right? That's authentication. I'm authenticating. They will validate that. Then when they say, okay, that's valid, authentication piece is done. Now let's encrypt the traffic. That's a separate thing. So keep that in mind. Now, IPsec is a network security protocol that provides encryption and authentication for internet communication. So IP security, right? Internet protocol security, exactly what it sounds like, right? It's going to encrypt the data payload of each IP packet and adds an authentication header, okay, which is used to verify the integrity and authenticity of the packet. So what that means is right here, you have your authentication header. It's a protocol, provides integrity and authenticity for IP packets, but does not provide encryption. So what's this mean? It's providing authenticity. It's saying we're validating this is authentic packet, but it's not providing encryption. That's where you got this, right? The encapsulating security protocol or payload. That is providing the encryption on it, okay? So this is a way to encrypt and authenticate, right? That's what they're doing. They're doing it with one protocol, but it's broken down into two, basically. Okay. You can have it in two modes. Transport mode. IPsec encrypts and authenticates data payloads of each IP packet, but does not encrypt the IP header. Okay, so what that means, the header itself is not encrypted, but that's the authentication piece, but the packet is encrypted, right? So you're sending it that way. And then tunnel mode, IPsec encrypts and authenticates the entire packet, meaning the header's encrypted as well, so nobody can see who's authenticating either. Okay, now, for example, admin can place a firewall in between in order to facilitate IPsec VPN traffic from a VPN client. Outside a firewall to a VPN server inside, the firewall would need to allow the following protocols. So what they're saying is if you put a firewall in place, the firewall has to allow this traffic. They have to have a rule that says allow this traffic or else it won't work. That's all they're saying. And that's, again, totally unnecessary to talk about this because I'm not even going to get into it, but this is not network fundamentals. The network fundamentals would be explaining how the authentication and encryption work. It's not explaining, okay, now let's make firewall rules to do this. That's a different piece, right? They just have it mixed and matched. It's just not cohesive in my opinion. Okay, point-to-point tunneling protocol. Also, network protocol allows creation of VPNs and works by establishing a secure tunnel between the VPN client and server. Cool. That's how a lot of them work, right? Open VPN right there. I just said it. It's point-to-point, meaning I'm connecting to you point to point, me to you. Okay. Now, vendor-specific information. I'm not going to read this to you guys because you guys can read. But what they're saying is this is true, not just network fundamentals and everything. Vendors do have some specific things, right? And you have to be aware of them. Some of the big players, right? Cisco's a big player in the networking, if not the biggest, right? Here's some of the things that they use, right? And so they're saying, here's some of the protocols they use: OSPF, BGP, switching protocols, VLAN trunking, spanning trunking, dynamic host configuration protocol, DHCP, which DHCP I don't think is vendor specific. So I don't know why they, same thing with access control lists. This just might be, they're just saying that Cisco has these specific things in their systems, but these aren't specific to neither spanning tree or any of these. So just know that they use this. But access control lists, super simple. It's a security feature. Hey, who has access? We set that, right? We set who can access it. Now you have your user, you have your password, your secret. The secret is a password to secure access. Okay. Enable secret. Okay. So not going to read that to you. So here's a good example of telnet that I was talking about earlier. This is something that you'll be using a lot in pen testing and things like that. Especially when you get started, if you don't know the protocol, you see they telnetted to it, right? And it's asking for valid verification. That's where the password comes in. And this is them connecting directly to the Cisco interface. Okay. Now, VLANs. Okay. This is where people ask all the time, what is a VLAN? Virtual LAN. Think about it this way. I have 10 computers over here, 10 computers over here, and they're separated. We're in 2 different buildings. We'll even go that far, right? They're on 2 different networks. They can't talk to each other unless we set up a connection, right? Well, VLAN allows you to do the same thing, but even if you're in the same physical location, I can take a switch and I can basically break them out virtually. I can say, this is VLAN 1, this is VLAN 2, this is VLAN 3, whatever, and keep them separate that way, right? That's great. They have their advantages and disadvantages, right? So here's a good example of it. Servers, they have all their servers on this VLAN, all their C-level executives on this VLAN, all their finance on this VLAN, all their HR, blah, blah. And you can see how each one, the VLAN itself, the IPs change as well, right? And that's why subnetting is important, because when you're breaking them out, you need to know how many hosts can I actually store on that. That's why the video before explained that. So here's some of the benefits, right? Better organization, right? It's not normal. It's not normally great to have just everybody in one bucket, right? That you shouldn't all be able to talk to everybody at a company. That's just silly, right? Increased security. Again, unauthorized members, I can set it up to where, hey, the HR people have no reason to be talking to the servers. Doesn't add up. Doesn't make sense. So VLAN 40, you can't talk to VLAN 10. It makes no sense. You don't need to, right? Increased security. Simplified administration. It's much easier to administrate because most of the servers are going to have similar things. Most of the finance are going to have similar things. Most, you know what I mean? I don't have to try to figure out individual and all that stuff. I can administrate it all from pretty easy stuff. Okay, increased performance. Without everybody talking on one VLAN, guess what? We stop collision. We don't stop it, but we prevent a lot more collision. We prevent that stuff because not everybody's actually talking on one network anymore. They're talking on their smaller networks and they're able to talk more efficiently. Okay, so Cisco VLANs provide numbers 1 through 4095 and reserved IDs cannot be used. Okay, so what that means is if there's a reserved ID, they can't use it, right? VLAN 1 is known as the default VLAN. This is your main VLAN, right? Should not be altered nor deleted. That's important. These are normal VLANs 1002 and 1005. So this is the reserved ones that we're talking about. Reserved for token ring, fiber distribution, VLANs. Again, these are just reserved for specific functions. That's all they're saying, right? So again, it's a standard. We all said you're not going to use these. We need these for something specific, right? Now, here's another one. VLAN.dat, right? That's a file that has parameters including name, type, state, and maximum transmission unit. Those are settings. You have to save them somewhere so that they know. That's where it's saved, right? So VLAN membership. So based on MAC address or protocols. So I can say you belong to this. These MAC addresses belong to it. Whatever. These ports belong to it. So I can say, hey, everything plugged into 1 through 20 on switch 1, literally physically plugged in, they all belong to VLAN 1, right? Everything on 21 through, 26, like whatever, that's VLAN 2, right? And you can do it that way. So you can physically address them properly, right? And that usually changes over the course of a business, because over years things get changed, all that stuff. That's why it's done virtually. Okay, access and trunk ports. This is important. There is a trunk or access port, right? This is where you can carry traffic of one VLAN, okay? So right here, any traffic arriving on an access port is assumed to belong to the VLAN port the port was assigned. Okay, so what that means is if you get traffic going over the access port, they're assuming you belong to the VLAN that port has. The port meaning the physical plugin, okay? On the other hand, trunk ports can carry multiple VLANs. What that means is you have one port, and a lot of times you'll see this if you go in data centers. You'll have switches sitting on top of each other, and the trunks, boom, it looks like a daisy chain. It's going boom, 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 boom. They're plugged into each other. It's because they can connect trunks. Think of trunks real big, right? Multiple VLANs. They are connecting them. So a good example of that is, I used that example before, port 4 or VLAN 40 should never be talking to VLAN 10, right? We said that before. Well, what if VLAN 50 does need to talk to VLAN 20, but only on certain things, right? Like there's an application that's using port 206. I just made one up, and I need it to talk on there. Well, I have to have a way to carry the traffic to the other VLAN because they're technically separated, right? That's where a trunk comes in. Okay, now VLAN identification. This is just the standard for identifying them, right? Inter-switch links, Cisco proprietary protocol, meaning that's owned by Cisco. That's what it means. Used for trunking, so that's how they do trunking, right? Now, this is the standard IEEE, Internet Electronics and Engineers, Electrical and Electronics Engineers. This is the standard they've developed for network packets, right? It's important because this is the frame. It's important to know how to break it down. You may never get to where you're directly manipulating the frames, but it's important to break it down because this is what has to be there. Okay, so or else it doesn't work. Everything has to work together, right? So you need your destination address, your source address, your header, and that's where this data comes in, the length, the data, and we're going to see this in action here. So you can read it, but we're going to see it in action, so I'm going to explain it a little bit. So now NICs, VLAN capable NICs, certain NICs, network interface cards, are capable of setting up their own VLANs that way so that the NIC can actually separate networks as if it's doing its own thing, right? It's small switch, if you will, kind of, right? So here they're showing how to assign that. So they're looking to see if it's 8021Q module. Okay, it looks like it's loaded. Here it is. It's loaded up. Now, what they're going to do is they're going to use IP, and they're going to say, okay, what's our interface? Our interface here is ETH0, Ethernet 0. That's the interface. Then they're going to use virtual configuration, add ETH0, and add 20. That's the VLAN they're going to add, right? They just added the VLAN, and then this is the same exact way to do it with IP instead of VLAN or instead of the vconfig. Now they said IP, and they looked at it again, IP address, and you can see now, because if you look up here, this is 2. You notice that? That's interface 2. Now they have this interface 4 that is ETH0.20 at ETH0, right? That's a totally different interface now, but all they did was virtually separate them. It's still the same interface. If you took that network interface card out of the machine, it doesn't work anymore. Neither of them do. So it's just virtually. Now you can see they went up here and they said, okay, add IP address, right? 192.168.11/24 to ETH0.20. So they're adding what IP, what subnets they want to add there, right? Now when you look at the difference. Here, they don't have anything. And here it just says broadcast multicast. Here, now it's telling us the interface is up. And here's the IPs, right? So they assigned it. Now, doing this in Windows, you go to Device Manager, and keep in mind, the reason they brought it up here is not every interface is capable of doing this, and that's why they talked about it. Okay, you go to your adapter, you go to Properties, you go to VLAN ID, value, you can change that VLAN ID to whatever you want, right? And then here they're showing you how to do that with PowerShell as well. So you can follow it, change it, do whatever you want. Be careful, because if you don't know what you're doing and you mess up you'll have to reset your configurations. But here's a good example. They're showing here, they're looking through the packet, looking through the packet, and you see this ID. So you remember up here, we did the 802.11, right here, the 802.1, excuse me, I said 802.11, 802.1Q, you have all this data that has to be in here, and then here's the header, and it has to have the TP ID, PCP, DEI, and VID. Now we come down here, and we look at it. Look at that. PRI, DEI, there's your ID right there, and it's 802.1Q protocol right there, or standard, excuse me. And you can see there's the ID 121. So they're on VLAN 121 in this video, or in this screenshot. But you can see they actually sorted on Wireshark for VLAN ID 10. And now look, they're only seeing traffic on VLAN ID 10. Why is this important? Well, if you're in security and you're trying to figure something out, well, what if you have a switch? You're just going to take a Wireshark packet of the entire switch and then look through it to find specific things? No, I want to find just the people talking on this VLAN. This is how you can do it. Okay, so now, additionally, to enumerate the used VLAN IDs from a packet dump, we can utilize T-Shark. So all they're doing here is they're saying T-Shark, they named it the ultimate PCAP, the fields, VLAN ID, and sort. And you can see they have 1, 2, 3, 7, 10, 20, 30, 40, 50, 60, 70, blah, blah, blah. There's your VLAN IDs that they actually used. Okay, now security implications and VLAN attacks. So these are attacks that are known for VLANs, right? They're fairly common if you get access to the actual network switch or something, right? So VLAN hopping. So this allows us to hop from one VLAN to the other, right? Makes sense, right? It's a protocol used to automatically negotiate the formation of a trunk leak. Remember, we talked trunks. Trunks are able to talk to other VLANs. We can automatically establish a trunk link to talk to those other VLANs. And guess what? Then we can hop to VLAN, right? Now, you can use this tool, Yersinia. You could do that. That's great. Again, this is network fundamentals. I have no idea why they're throwing this in here. I think this is a terrible display. You can say VLAN hopping, explain what the attack is, and move on. Showing the tool and all that stuff, it's got nothing to do with network fundamentals. You're talking way over the head of people learning networking. So now double tagging, VLAN hopping. Again, I'm not going to explain this to you. You guys can read it. It's a more complex attack where they actually tag it with multiple VLAN IDs, and that way, when it actually is read, it can be read into the wrong VLAN, right? You can dive into it. I think it's a waste of time currently. I think after you understand networking a lot better, go back and read it, but I don't think it's a smart use of your time here. Okay, so now VXLAN, we mentioned previously that the VID field within the 802.1Q header inside an Ethernet frame is only 12 bits. They talked about that if you read it, allowing for 4,094 VLANs. That's what we talked about. That's great, and it sounds like a lot, but if you have a data center, 4,094 VLANs is not very much. So they had to change that, right? So you can see currently this is 802.1D. They use a spanning tree protocol. We saw that one earlier. We talked about it a little bit. That's great. It ensures loop-free technology, meaning your packets aren't going to loop through, right? So it prevents a lot of that. The problem is, again, we talked about that smaller scale. If you have a data center like Google or Amazon or something, they're huge. So when that happens, you have to change to virtual extensible local area network. Essentially, layer 2 overlay scheme on layer 3 network, okay? So what this does, it fixes those limitations on that layer 2 networks and caters to the requirement of layer 2 and layer 3 data center network. Blah, blah. Basically, it allows you to make much larger scale VLANs, and it allows in a multi-tenant environment with virtual machines, okay? Operating over the existing network infrastructure, VXLAN provides an innovative way to seamlessly extend a layer 2 network. So if you have a layer 2 network, you can now add it to basically layer 3 is what you're doing. You're extending the capabilities. Okay, so now ensuring that only VMs within the same VXLAN segment can communicate with each other. So most people know that VMs are pretty much how a lot of companies do business. There are still physical servers, don't get me wrong, but typically you're going to look at something like an ESXi host or something like that is then going to set up all these virtual machines. Well, if they're virtual, quote unquote, right, then I don't need a physical switch for them, a layer 2. And they're saying I can actually extend that up to a layer 3 and virtually allow it, right? That's what they're doing. So now Cisco Discovery Protocol, this is a protocol that's exactly what it says. It's to discover things on the network. This can be turned off if from a security perspective, you should turn it off unless you need it. STP network traffic. All right, got a call. Okay. In this example, we see that STP message was sent containing information about the root switch, the MAC address. So again, STP network traffic, it has the information we're looking for. There you go. Okay, key exchange methods are used. Okay, between two parties securely. So this is the key exchange that we were talking about earlier. That key exchange is to actually set up a encryption. So there's asymmetric encryption and symmetric encryption. Symmetric encryption is where we share this key, okay? And what that means, it can look like anything. It can look physical. I could literally physically give you like a USB that is your key. You plug it in and there's your key. It could be using asymmetric encryption to actually exchange that key first. And we're going to talk about that. So here, key exchanges, think of it as a key to your house, right? If I want to talk to you, I have to come in your house. So I have to have the key, right? So you have Diffie-Hellman exchange. I'm not going to get into this is again, it's clustered. It doesn't make any sense to be teaching you guys key exchange to this level on network fundamentals. And you may disagree with me 100%. And if you do, that's fine. I totally understand your perspective. I get that this is part of network fundamental or part of networking, but it just is not where my head would go if I was, yeah. So, okay. So now one of the main limitations of Diffie-Hellman is it's vulnerable to man in the middle. So again, Diffie-Hellman, nobody really uses that anymore. It's deprecated as well. RSA is still in use. Reves Shamir Adelman, I don't know how to say his name. But anyway, that's how a lot of these mathematical algorithms are created. When they're created, they're named after the person that created them, right? So again, you don't have to read it too much, but it uses the properties of large prime numbers it's a math equation, right? It's a math algorithm. So now this will actually allow you to encrypt and sign messages to provide confidentiality and authentication. So protecting data in transit. So all you need to know out of this whole thing is the different algorithms encrypt the traffic differently, right? And we need to get you the key, okay? So this is elliptical curve. I'm not going to cover all this because, again, you don't need to know that for networking fundamentals, right? And by the time you actually spent the years it takes to learn in cryptography the proper way, these algorithms will probably be deprecated. So, okay, so here's the reality. Protocol used to establish and maintain secure communications such as those used in VPNs. So there's two things that you need to know. You can look at Ike if you want and read this if you want. There's two things you need to know, symmetric and asymmetric. Okay, so you have, and we'll talk about it. So pre-shared key is a pre-shared key. If I call you on the phone and say my key is 1, 2, 3, 4, 5, 6, 7, 8, 9, and you put it in and we have an established encrypted connection based on that key, that's a pre-shared key, right? Problem with that is, how do I get you that key? Because I have to get it to you securely. Okay, so am I going to call you? Because that's not very secure, right? Are you going to write it down? That's not very secure. Like, how are we going to do this? So that's where asymmetric encryption comes in. And what they do is they have a public cert and a private cert or key, whatever you want to say. And the way it works is when I send you a message, I pull your public cert down and I encrypt it. I encrypt our traffic and using your public cert. And the only way to decrypt that cert is using your private cert that you have. I don't have it. So if that packet gets lost, if that data gets lost, it can never be decrypted. eventually maybe, that algorithm will get broken. But they do that. They establish that connection using asymmetric. Once they do that, we then share an encryption key over that encrypted channel, because that's very slow. If you think about it, every time I have to pull down encrypt it using that, then you have to decrypt it using your private key, whatever. And your private key is never shared with anybody. Then once we have that connection, we share a key, right? Pre-shared key over that connection, and we switch to symmetrical because it's much faster, right? So that's all you need to know about it. I'm not going to, you can read it if you want. You can tell me I'm an idiot. I don't really care. That's what I think you need to know for this piece. Okay. So now we have authentication protocols, because remember, encryption and authentication are different. So, all right. And again, don't think this is necessarily super relevant for network introduction to networking, but let's go ahead and get into it anyway. So authentication protocols basically prove you are who you say you are, right? So you have Kerberos. This is very common. You have your key distribution center. You basically authenticate to Kerberos. They give you a ticket saying you can access whatever resource you were requesting. You show that ticket to them. They validate it. Boom, you're in. I'm not going to dive deep into all these, right? Because it's not something you need to know. So TLS. TLS is a cryptographic protocol that provides communication security over the internet. Encrypts the data over the internet, right? The reason it's an authentication protocol is because you can see that some authentication systems use TLS to encrypt the data. 2FA, two-factor authentication. These are just terms at this point, right? They're not really talking much. And again, why I don't really like the data. So now, as physical connections, protocols of SSL, TLS. So SSL is deprecated. TLS is taken over SSL. Just know that. Both protocols use robust encryption algorithms to protect the authentication information transmitted between the client and the server. That's what you need to know right there, is when you connect to something, you have an encrypted channel to share that communication. TLS, things like that, those are what HTTPS is using, right? So you see HTTPS, secure shell, anything like that, they are using encryption after you authenticate. They're encrypting that traffic, and they're using those protocols to encrypt that traffic for the rest of the session. So understand that. And then you can see they support using digital certificates and PKI for authenticating. So that's what I was talking about before. They didn't dive deep into it. They just kind of talked about the protocols, but that's what it is. Now, TCP, UDP connections, we don't have to get crazy into this either. The big thing is that I explained what TCP is and what UDP is. Make sure you know the difference. You can see, if we go down here, this is what the header contains of the IP header, okay? So this is something you will need to see, and I wish they would, let's see if they have a picture. They don't have the picture of it, but there's a picture that shows the actual, kind of like the way they did with the frames, and that's how it's a little easier to see from my opinion. But so this is what's going to be in the header of the packet, right? The version, which version of IP protocol are they using? The internet header length. So how long is this header that I expect? Because should I wait a while to see if I'm going to get the rest of it? Whatever. Class of service. How important is the transmission of the data? Is it critical? Because if it's critical, then this needs to go priority over anything else. Total length. How big is the packet, right? Identification. Is it packet 1, 2, 3, 4, right? Obviously, that's not the actual name or convention, but flags. Is there a push flag, ACK flag, acknowledge, whatever? Fragment offset, right? So this is indicates where the current fragment is placed in the packet. So it's, long story short, it'll tell you what's going on. Time to live specifies how long the packet may remain on the network. So again, we said this before, if you have a time to live of 3 and it's hopped 3 times, it's done. Get off. This prevents loops. So what happens, what used to happen in networking is if you accidentally made an error and you send a packet to something that maybe doesn't exist or whatever, it's just going to keep circulating, looking for it forever, right? We need to not do that. Protocol. What protocol are we actually using here? TCP, UDP. Checksum is used. This detects errors, right? The checksum is, when you get it, you check it against the checksum and it validates, and boom, there you go. You know there's no errors in it. Nothing changed. Source, destination. This is obviously the source and the destination. Options contain optional information. Padding. This pads the packet to a full word length. What that means is if there's something missing, the pad will add basically the amount of data needed to fill that space. Then we know that there's 65,535 unique IPs, right? That's the most that you can, or ports, I'm sorry, that's the most that you can have. Okay, so if a computer has multiple IP addresses, which just happens when you're dual homed is what it's called, the IP ID field would be different for each packet. So what that means is you can actually filter it out based on where that traffic would go. So if you have an IP address externally facing, if for like you have a website, and then you have an IP address internally facing, both on the same server, one's to access internal resources, one's to access external, I can sort them out, right? Meaning I can look at, I only want to see the stuff that's going internal. I don't care about the people accessing the website. I can do that, right? So that's what they're saying. Okay, the record route field in the IP header also records the route. So it's telling us how did it get there, right? Because maybe it makes sense for you to go from my website to my firewall to my SQL database. It doesn't make sense if I check the routing and you went from my from my website to my firewall to my domain controller to my file server to that would be weird, because it's like, why are you routing that way? So that's kind of just showing you which way you're routing. The other thing that this is nice is if you're like a network engineer or something and your routing tables are messed up, you're like, why is it going this way? That's not the fastest route. That doesn't make sense. You can actually track it down. Traceroute does the same thing, allows you to trace what's going on. IP payload, also referred to as the data, is the actual payload of the packet, the actual data, right? What's actually being sent. TCP packets, also known as segments, are divided into several sections: headers, payloads. So the header is what we saw before. That's your source, destination, all that stuff. That's getting it there, right? The packet is actually what's the payload is what's actually you're sending to them, right? If I send you an email, I need the header to tell them where it's going, what it's doing, what kind of email, protocol reason, all that stuff. But the email itself is in the payload. Okay, UDP, small data packets between two hosts. Connectionless, meaning it doesn't establish. Okay, and it feels like we're actually at this point just kind of reiterating. So now blind spoofing is a meta method of data manipulation attack in which an attacker sends false information on a network without seeing the actual responses sent back by the target. So what that means is we're gonna basically manipulate the header, right, to a false source and destination, right? So for instance, if I know you can talk to so-and-so, I may send that, right? Okay. The problem is we're not going to get that response because we're not the IP that we asked or that we said we are, right? We're sending it to you, right? So that's why it's blind, because you're not going to see it. But here you go. It disrupts the integrity of network connections or breaks the connections between network devices. So you can also, there's ways to make it not blind eventually, right? So things like that. All right, let's see what else we got. All right, we're on the last one, cryptography. This is what I was talking about with the symmetric and asymmetric encryption. The asymmetric, you have a public key and a private key. You guys can read a little bit more about it. I already talked about it. That's what I think you need to know about to understand the protocols that are using the encryption, which is what they were talking about down here in the actual key exchange mechanisms and stuff like that. But the data encryption standard, again, by the time you get too advanced into this, it's going to probably change these encryption standards all the time. When I say all the time, I mean every 10 years. Every time computing gets better, these have to change. They have to. They can't keep up because they can get decoded or decrypted. So that's why you see all these different ones. You can read this if you want. It'll tell you which ones are best for certain purposes. But unless you're going to get certified in encryption or cryptography or something, it's not necessarily important that you know the math behind it. Okay, it's important that you understand what each one's used for, which they do provide here. So this was a long box, a lot of just reading, which is why I didn't want to just read it to you. I want you guys to go through it. Let me know what you guys think. If this helped you at all, if it didn't help you, let me know. If you thought this was a waste of time, perfect. But I wanted to get this box finished and out to you guys because I know a lot of you guys have been waiting on it. So thanks, guys. Hope you guys have a great day.